In each person. Yeah. All right. Um, Here we go. Come on, come on, come on. So, this lesson is a small lesson, but it's very important for one of your experiments. Mm, The pendulum. Yeah. Okay. Got this title? You got the title? Yeah. Yes. Me too. And coffee. And chocolate. And sausages. For free. Oh, very nice. That's what I need. I won't get it though. Okay. Do you have this title? The pendulum. So, Grace, you know what a pendulum is. Show the class. That's a pendulum. Yes, very good. So we're going to have a look at the pendulum today. Oh, so small. Let's fix that. So this is a picture of a pendulum. Let me zoom in for you. Well, maybe I'll just draw it. Yeah, here we are. Zoom. Where's zoom? Zoom in. There we go. So, a couple of keywords. Usually this has no mass and all the mass is at the end. The middle here is the equilibrium and this is the path. This is the angle here. I think the most important word is pendulum really. But if you can draw this, it would be great. The bob is massive, it has mass. The pendulum rod is massless. Yeah. The string, effectively. Okay, can I continue? No, not yet. Yeah. Okay, let's have a look at it. Right, so here is our pendulum. And it's gonna swing around like this. And this here is theta. So let me draw in the forces in black. So what force is this? Weight. Yeah, weight. And then here? Tension. Now this is tension. But if this is theta, whoa, no. What's this angle here? It's theta also, isn't it? So is this T cos or T sine? T sine.
T cosine. Oh,
Because here's the theta. And then this one here.
T sine. Oh no.
Sorry, I'm drawing that badly. But here.
T sine.
T sine theta. Now this force here and this force here cancel. The only force that doesn't cancel is this one. Why not?
Because no force cancels.
No force cancels, yes. And also, it's what's making it go to the left. So this force here is the one we care about. We care about this one. It's making it go to the left. Okay. Right. Now, I have to draw a triangle to my side. Can I go to the side? Not yet. Can I go to the side? Yes. Sophie? No? Yes? Okay. So look at this picture. This is Al. This is Al here. And it swings down like that, correct? Now this is, I'll draw that better, that's ugly. Now I know it goes from here to here, but the blue is nearly the red, isn't it? Like, I mean, there's not much of a difference. If I call this here X, and this one here is called arc, you can see that or maybe I'll call it S actually. You can see that the S is nearly the same as the arc. It's not much of a difference, especially if the angle here is small. True?
Yeah.
Now, sine theta is roughly equal to the arc divided by, and if I make this 90 here, what's the hypotenuse? The L. So the sine theta, it's roughly the same as the arc over L. Maybe I'll call this here X. Well, yeah. X over L. And cos theta, that's roughly equal to what? What would cos theta roughly equal? Can you see? It looks a bit weird. What is it? L over L. Because this is the adjacent and this is the hypotenuse.
I got mixed up. One?
Yeah, now I know that seems very strange, but I can help you see this on your calculator. Yeah? If you put your calculator in radiant mode, can you do that? Radiant mode?
There is no radiant mode.
Oh my goodness, there is. Shift mode radiant. Now,
ARC?
Oh, I see it.
A or C, arc. Yeah.
What is arc?
It's the name of this part. You need to check the circle lesson. Right, what is cos 0.10?
0.995.
So it is near, if the theta is small, it is nearly 1.
One.
Yeah. So anyways, I just need that before I go back here. Yeah.
No.
Oh my goodness.
No, but listening to you was fine.
That is good. Both would be best. Yes?
No.
I'll give you 6 more seconds. 5, 4, 3, 2, 1. 500 milliseconds. 100 milliseconds. 0.
Okay, then.
Okay. So look, we know that cos theta is roughly equal to 1. So we can cancel this and we can say that t is roughly equal to mg. And if I put that in here, you get mg sine theta is this piece here. But what does sine theta equal roughly? X over L, where x is the distance here it travels. So that becomes this now. Now I'm going to put in a minus. Why am I putting in a minus here?
Doing the.
Because it's going to the left. And what does this equal? This is the force. Now it's roughly. For what?
It's going to
The left.
Yeah.
Mhm.
But the force
One
is
sec, wait. One at a time. Yours first, Sophie. Yeah, from the beginning, from the mg part. Yeah, okay. So I'll go back in time. Back to here. So we know that t cos theta should equal mg. We okay with that? And we know that cos theta is roughly 1. So that means t is roughly mg. That's okay. Now if I look here, you have the force to the left is equal to minus t sine theta. But t is roughly mg. So this is equal to minus mg sine theta. But if you were to remember here, sine theta is roughly x over L. So here, this is roughly, if this is the x, it's roughly x over L, minus mg x over L. This is the force to the left.
Is it the formula?
No, we're getting to the formula. What? Force, this is F here. This one.
But where this force is going towards the
Going to the left.
yeah, but you know the force is pulling in this direction, so it's in the direction of force.
Oh, I know, we're saying it's roughly horizontal. Roughly horizontal. Minus t sine theta? I'm saying this one. Is that a yes or a no? I don't understand.
We care about the minus of the.
A little bit. We care a little bit. I'll put the minus in. Continue? Yeah? What's wrong? L. Yeah. Sine theta. Here's theta. Sine theta is x over L. It's a triangle. This is L and this is x. Sine theta is x over L. I feel confusion. Are we good to continue, or do we need to ask more questions? We think we can continue?
Why is minus now?
Why the minus? Which way is it going? Left or right? Hmm?
Go right?
Correct. Got this?
No.
No. So we're trying to get to a formula here. That's what I'm doing. Now, this is important because this formula, you will need to include it in your lab report.
Lab report.
What lab report?
Next semester.
You use lab?
Where are we gonna do experiment?
Yeah.
Where?
Very dangerous experiment. I'll tell you later. Okay, continue.
Yeah, blow up.
Now, yes, blow up indeed. F is equal to what from Newton's second law? MA. So you have MA equals minus mgx over L. What happens to the m's? They cancel. So now you get A equals minus g over Lx, or S, whatever you prefer. I'll call it S. You can call it X, it's the same thing. Now, watch this. Let omega be equal to root g over L. So what does this formula become? It becomes A equals minus, if I use this, what does this become? What's this? Is it omega?
Yeah.
No.
Square root omega.
No.
Square omega.
Thank you.
Yeah.
Does this formula look familiar?
Yeah.
It's the formula for what?
Simple
Simple
harmonic.
harmonic motion. So therefore, this is simple harmonic motion. Therefore, what's the formula for time? Do you remember?
1 over frequency.
And the other formula?
Or
There's two formulas. 2 pi over omega. So this gives you the result. T equals 2 pi root L over G.
Which one about
Everything, but this is what we wanted.
everything?
Yeah, because I want you to include this proof in your lab report.
Yeah, but here the omega is in the dominator and it is L by G. Oh, it's okay, noted.
Well, it was 2 pi over omega,
Yeah,
and omega is G over L.
yeah.
So 1 over omega is L over G.
Oh yeah. So they are
I flipped it.
flipped.
Yeah. Some people remember this formula.
No.
No?
Not me.
No? Toby?
Only so.
You remember this formula? No? You two? Did you do this formula in high school?
Yeah, we did, but don't remember it.
Yeah, okay. So nobody remembers it. I need the proof in your lab report. Yeah?
Can I copy?
No,
Right.
no.
Copy? Copy and paste? No.
You can just watch the video later and get them.
That's what everybody thinks, but nobody does that. So let me give you an example of this. No, I need something like a string. Do we have a string?
String.
String.
No.
No? Or a ruler? Give me that small ruler. Oh, it's really small. Dude. Yeah, come on, give it. Give me! Give me!
To connect it first, then it'll be easier to show.
Oh, but then it's shorter.
Yeah.
forget it. Okay. Um, doesn't matter. We'll have to use our imagination. So yeah, imagination. So what you have is your pendulum, and you pull it back, and you let go, and it starts to swing. Yeah. So this formula can tell you the time to go from the start and back.
One oscillation.
One oscillation. Okay. So I don't think this will work because my fingers are too big. But if you could try and hold it and then pull it and let it move, we could get the time. Does anyone have another ruler with like a little hole in it?
There.
Better. Give me that. Right. Do we have a nail or a pin?
Here on the board.
You can use a rope, like from projector.
Oh yeah, give me that. Give me that.
There.
Pin. Yeah, yeah. Give me that. Give me that. All right. So the length.
You can use a rope.
No. We'll manage with this. All right. So there we go. Okay. So the length. Well, it would be from here to here. So that's 15 centimeters. And then can you measure this piece? Can you measure this piece? Measure with your ruler. This is an inch. Oh no. Okay, so we'll say, hang on. Right. Right. So this is 18 centimeters. 18 centimeters, which is 0 from the bottom to here. 18 centimeters, okay? So if you put in 0.18, can you tell me what the T is, please? In the formula. Come on. 0.18, what's the T?
What is
The length. The length.
L?
Yes.
What is the
That's what we're calculating. The
Yes,
time to
what-
go once.
What would you say at pi?
G is 9.81.
What is it again? 18, right?
18 right?
0.18. Doesn't matter.
18 it's 9.9
9.81.
8.5
8.5? No.
No, wait, let me do it.
8.1? 8.1.
something
0.18 is the length.
ah 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 0 point
Yeah.
0.85
0.85.
Oh, this is better.
1.79?
Yes.
something wrong
0.18.
Oh.
18.
0.85
0.85.
yeah
You got that?
No.
Yes. Now look. Look, look.
Look. What is this? Better.
Enter. Let's see.
Enter what?
Let me see what you typed in.
How do you do that?
Because your brackets are in the wrong place.
Oops.
And it's 0.18 is the length, not
Got it.
80.
Oops.
Right. So the time, you're keeping silly today. The time is 0.85 seconds. For how long? For 1.
Yeah.
So how many would 10 take? If 1
1.
takes 0.85,
yeah
10 would take
8.5.
8.5. Right, take out your stopwatch. Let's see. Stopwatch.
what
Stopwatch.
mine is big
That's fine. So how long do we think it should take for 10? 8.5 seconds.
maybe
That's my phone.
Are you ready for the stopwatch?
no
Yes.
I'm not
Yeah.
familiar
One.
with my phone
Yes.
Now I'll say start.
no
No, actually you say
Okay.
start and then I'll say stop.
stop
Wait.
1,
Wait.
2.
He's going to say start.
yeah
That's when you start also. We'll get two
yeah
numbers.
yeah
Okay.
1, 2.
No. Oh, sorry, you're counting down. No, 3, 2, 1, go.
3, 2,
2
1,
1
go.
go
1, 2, 3, 4, 5, 6, 7, stop.
5.9.
5.45
Okay, well this is very bad pendulum here.
6.02. I got 5.9.
5.45
5.93.
Bad pendulum. make it a little. No, doesn't work. Well, if
You
it's,
took a good idea.
you get the idea. You get the idea. So in the experiment, you'll have a nice pendulum
Why
here.
did you do this?
No, this is enough messing around with this. I don't know. There's enough.
No, you can disconnect the pen from our way,
Oh yeah.
and then now it will swing.
That's a little better. Ah, doesn't matter. We got a real pendulum next time, okay?
Yes, yes.
Alright. So, homework for this. That was all I needed to show you. Yeah, so my question was 1 meter, and in the class I did 0.18. You get the idea though. Okay.
Oh my. Oh.
What?
Oh.
Oh, good. Can you send this to Eric?
Okay. This is what's this?
The question.
I can see.
It's only one question.
I'm thinking of only
Only
one.
one question. Question
No,
one,
no,
that's
no.
all.
Oh, that's a very
Big, very big one. Can I give up?
You should try before you give up. Yeah.
That's
And if you don't tell me, I will give up too.
yes.
It's long, it's easy, but it's just long. But it's easy.
Which one?
Using
No, they're all easy. Oh, every part's easy.
Yeah, that's
using which formula is it? Simple harmonic?
The formula I gave you today,
Yeah.
and the formulas in the last class.
That's right, yeah.
Yeah.
回家，
What?
回家，
What's
go
your
home, go
graduation?
home, leave home.
Why are you in English?
I want to go home.
I know.